Hello, scientific computing is nowadays the third pillar of science, standing next to the theoretical analysis and experiments for scientific discovery. Computation becomes crucially important in situations such as the problems at hand cannot be solved by traditional experimental or theoretical means, such as attempting to predict climate. Experimentation may be dangerous, like characterization of a toxic material. The problems would be too expensive or time consuming to try to solve by other avenues, like determination of the structure of proteins. There are several computing tools, some of are commercial and others are open source software like MATLAB, Mathematica, SPSS, Maple, R or Python, etc. The entire discussion deals with Python is an open source software and it uses in basics, applied and sciences. There are several computing tools, some are commercial and other are open source software like MATLAB, Mathematica, SPSS, Maple, R, Python, etc. The entire discussion deals with Python is an open source software and its uses in basic and applied sciences. The main agenda of this lecture is Sympy, a Python library for scientific computing. Sympy is a Python library for symbolic mathematics. It aims to become a fully featured computer algebra system while keeping the code as simple as possible in order to be comprehensive and easy extensible. Sympy is written entirely in Python. Why Sympy is so important and useful for scientific study and to study basic and applied sciences? There are main four reasons. The first reason is it's free licensed under BST. Sympy is free both in speech and as in beer. Second reason is Sympy is entirely written in Python and use Python for its languages. So we can easily use Sympy in the Python programming, which is open source software. Third is lightweight. Sympy only depends on MP-Math, Python library for arbitrary floating point arithmetic, making it easy to use. And last one is beyond use as an interactive tool, Sympy can be embedded in other applications and extended with custom functions. There are several projects which are associated with Sympy. The very first is Cadabra. It is a symbolic computer algebra system designed specifically for the solutions of problems encountered in the field theory. It has extensive functionality for tensor computer algebra, tensor polynomials, simplifications including multi-term symmetries, permanence and anti-commuting variables, Clifford algebra and pairs transformation, component computations, implicit coordinate dependence, multiple index type and many more. The next very important package is MPy, a package useful for chemistry written in Python. It is a Python package useful for chemistry. Currently it includes numerical integrations, routine for chemical kinetic, integrated rate expressions, solvers for equilibria. EinsteinPy, it is an open source pure Python package dedicated to the problems arising in general relativity and gravitational physics, such as geodesic plotting for Schwarzschild Kerr and Kerr-Newman space-time model, calculation of Schwarzschild radius, calculation of event horizon and ergosphere for Kerr space-time. Symbolic manipulations of various tensors like metric, Riemann, Ricci and Christopher symbols is also possible using the library. Fourth is a very important package, OctSympy, which adds the symbolic calculations features to GNU Octave. These include common computer algebra system tools such as algebra operations, calculus, equation solving, Fourier and Laplace transforms, variable precision arithmetic and other features. Compatibility with the other symbolic toolboxes is intended. Octlang is one of the most important packages which deals with the Sympy. It is a Python package for solving mathematical optimization problems such as maximizing or minimizing an objective function or a set of variables subjected to the number of constraints. Octlang provides a common interface to a series of optimization tools, so different solver backend can be changed in a transparent way. PyNicis is a solver symbolically defined system of nonlinear equations numerically. It provides a convenience class of representing resolving nonlinear equation system from symbolic expressions in addition to deriving the Jacobian analytically, and the symbolic representation can be example, apply, reduce. This is useful for when we have overdetermined system and want to solve this system by root finding rather than using least square optimization. So this is very useful and important tool for nonlinear equations. PyODCs is one of the important tool which deals with the differential equations. It provides a straightforward way of numerically integrating system ordering differential equations. It unifies the interface of several libraries for performing the numerical integration as well as several libraries for symbolic representations. It also provides a convenience class for representing and integrating ODE system defined by symbolic expressions. This allows the users to write concise code and rely on PIODCs to handle the subtle differences between libraries. A common problem when learning quantum mechanics is the complexity in the mathematical and physical concept which leads the difficulty in solving and understanding the problems. Using programming languages like Python have become more and more prevalent in solving challenging physical systems. An open source computer algebra system, Sympy, has been developed using Python to help solve these difficult systems. Last one is scikit-fdiff. This is very important library. The aim of this library is to have easy way to write a transient system of n-dimensional partial differential equations and with finite difference discretization and fast temporal solvers. The main two parts of the library are first is symbolic tool defining the spatial discretization with the boundary taking into account in the separate part a fast temporal solver written in order to use the sparsity of the finite difference method to reduce the memory, and the second is the CPU uses during the solving. Moreover, extra tools are provided and the library is written in a modular way, allowing an easy extension of these different parts. There are several more libraries which comes with Sympy, but due to lack of time we are not introducing here, but in the coming sessions we will target all these libraries one by one, and we will try to present all these library with examples, with experiments, and I hope the coming lectures will be very helpful for all of you. Thank you very much to see this lecture till the end.